Hi, this is Sandhya. Today I am going to tell you about Butterworth filter. In this video, I am going to tell about what is Butterworth filter, who invented Butterworth filter, and first order LPF design, finally some derivations. Listen. First, what is Butterworth filter? Remember one thing, it is a signal processing filter. Butterworth filter is a signal processing filter and it is designed for maximally flat frequency response. In which band? Pass band, that is band pass filter. Next, who invented Butterworth filter? One British engineer whose name is Stephen Butterworth. He is the one who invented Butterworth filter. Stephen Butterworth, who is a British engineer, he invented the Butterworth filter. Next, I am going to tell some important points. Keep in mind what are they means. First, the frequency response is flat. Frequency response is flat in band pass filter. In which filter? Band pass filter. And roll off to 0. Roll off to 0 in stop band. The bands are so important. Frequency response is flat in band pass filter and roll off to 0 in stop band. The second point is rate of roll off. Rate of roll off depends on order of the filter. Rate of roll off depends on order of filter. This is so much important. Rate of roll off depends on order of filter. Next, which decides order? We all know the reactive elements. What are the reactive elements we know? The first one is inductor and second one is capacitor. But here capacitor only used. Inductor is not used. So the order of filter is decided only by number of capacitors in the circuit. Okay. Next, these all are speaking only in band pass filter. We can also design in LPF, that is low pass filter, and HPF in high pass filter by doing something, that is LPF and HPF. We can also design in LPF and HPF by changing the position of resistance and capacitor. Next one will be design. How to design the Butterworth filter. There are some components in designing a Butterworth filter. First one is op-amp. It must be operated in non-inverting mode. Next, capacitor and resistor. This is the way we used to design the Butterworth filter using that component. We all know this is an op-amp symbol. It is operated in non-inverting mode, so minus and plus. Next, the output is grounded. V0 will be the output voltage. Next, only one capacitor. Why? Because it is first order. That is also grounded. Next, the input voltage V in and one variable resistor R. That is also grounded. The next input has one RF resistor and R1 resistor. So this is the design of first order Butterworth filter. This is op-amp and this is capacitor. For first order only one capacitor and this is variable resistor R1, RF, V in input voltage and V out output voltage. These all are the design. Here gain is decided by R1 and RF and cutoff frequency is decided by capacitor and resistor. Next one will be first order filter LPF design. By increasing the order, the cascaded stage is also increases. The mathematical flat frequency response is up to minus 3 dB. Frequency above cutoff frequency will decrease at the rate of minus 20 dB. Increase the order will increase the rate of roll-off period. In simple, we can say this in the simple way that by increasing the order, that increases the cascaded stage, as well it increases the roll-off period. Simply remind this will help. Next, nth order formula. H of j omega is equal to 1 divided by root of 1 plus epsilon square omega divided by omega c power 2n, where n is the order and omega c is a cutoff frequency, epsilon is a maximum passband gain and omega c is cutoff frequency and omega is operating frequency. Here h1 equal to h0 divided by root of 1 plus epsilon square. Here h1 is minimum passband gain and h0 is maximum passband gain. Next one will be a LPF first order design. Here it allows only lower frequency, that low frequency signal when compared to low frequency signal when compared to that cutoff frequency, that is FC. Here we apply voltage divider rule at VA. We are familiar with voltage divider rule. We have to apply it in a VA at the point VA. VA is equal to minus JXC. We know the capacitor is one of the component, and R minus JXC, a resistor is another component, along with V in input voltage. XC is a capacitor, R is a resistor, and V is a input voltage. Here we have to replace XC is equal to 1 divided by 2 pi FC. When we replaced VA is equal to minus J 1 divided by 2 pi FC divided by R minus J 1 divided by 2 pi FC into V in. Here taking out of 1 divided by 2 pi FC out, that is 1 divided by 2 pi FC divided by, here no 2 pi FC, so multiply and divide by 2 pi FC in R, so 2 pi FC R minus J whole divided by 2 pi FC into V in. 2 pi FC getting cancelled, so remaining minus J divided by 2 pi FC R minus J into V in. This is VA value. Again taking out of minus J outside, minus J divided by, here no minus J, so multiply and divide by minus J 2 pi FC R minus J divided by J into V in. Again V is equal to V in divided by 1 minus 2 pi FC R divided by J. V is equal to V in divided by 1 plus J 2 pi FC R. In simple, minus J in denominator goes as plus in numerator because of non-inverting configuration. The output voltage V0 is equal to 1 plus RF divided by R1 into VA. Here we have to substitute the value of VA. That is V0 is equal to 1 plus RF divided by R1 into VA, that is V in divided by 1 plus J 2 pi FCR. This is the output voltage V0. Again, we know the frequency, cutoff frequency FC is equal to 1 divided by 2 pi RC, and psi is equal to minus tan inverse of F divided by FC. This is. Now I'm gonna summarize this Butterworth filter. What is Butterworth filter? It is a signal processing filter. This is designed for what? Maximally flat frequency response. In which filter? Band pass filter. But we can also design in LPF, that is low pass filter, and high pass filter by changing the position of resistance and reactive element. Here the reactive element is only capacitor, no inductor. The design consisting of op-amp, capacitor and resistor and input voltage and output voltage. The number of capacitor decides the order of filter, that is first order or second order or third order. If the first order filter consisting only one capacitor, as like this. And from the derivation we have to find value of V0, that is output voltage, by applying the voltage divider rule at the point VA. Here the op-amp operates in non-inverting mode. Finally, the application. It is used majorly in audio process, that is in communication, to ensure clear signal fix without any distortion. We can get the clear signal without any distortion by using this Butterworth filter. Just remind this.